Good afternoon, everybody. My name is Paulo Hubert. I am a PhD student at the Applied Math Department at the University of São Paulo. I'm going to talk a little bit about equilibrium concepts in maximum and maximum entropy in macroeconomics. Why am I going to do that? Since I am not an economist. Well, it started when I took a one-semester course called Microdynamics at the Economics Department at the University of São Paulo, which was taught by Professors Gilberto Tadeu and Laura Carvalho. I have some interest in economy and macroeconomic models. And also I am interested in understanding the use of mathematical models outside of the more traditionally quantitative fields like physics. So that's why I went there. And it was very interesting to see how they translate the concepts and methods of mathematics in economics. And also it was interesting because from the last, I don't know, 10 years maybe, there has been some very hot discussion on the use of these kinds of methods in macroeconomics. So we're gonna get there. Well, I believe that we all know that the quantitative method was a huge success starting in physics, probably since Galileo, Descartes, and Newton. The use of mathematics in the physical sciences was very successful, both empirical and psychologically. I say psychologically because I think, for instance, in the prediction of the existence of the planet Neptune by Newtonian rational mechanics methods, before anybody could see Neptune with a telescope. So it made a huge impression on people that by using mathematical rational methods, we could predict so many things, astonishing things about nature. So these kinds of successes put mathematical methods in the order of the day for science. And it started to be widely applied in many fields. Social sciences were a field that was quick to follow and to start using these kinds of methods. So I went there, when I was taking this course, I had I was studying to build a paper for the course, which later developed in this paper. And I did a little bit of studying the history of economics. I was trying to find, to trace some uses of the concept of equilibrium, because nowadays economics in equilibrium or equilibrium models are very important in economy right now. So, well, for the use of mathematics, I've found many economists like Samuelson and Debré who tried during the 20th century to create a theory for economics which is founded on mathematical methods, on axiomatization and things like that. And they did that. There are many instances of direct translations of physical concepts into economy. So value as substance, as matter, or sometimes as energy. Economy is a science that deals with value, which is something that is quantifiable easily. So it was a great, right? It was also easy for them to make this translation. And Samuelson, for instance, he makes quite a direct analogy between the methods of theoretical physics and what he was trying to propose as the method of economic analysis. So he says about the good view of theoretical physics is that you assume second-order differential equations which are sufficient to determine the evolution of the system, and you try to understand what is going to happen with that system in the future. And in the field of economics, he's trying to do the same thing. So this analogy between physics and economics is very clearly stated or seen in the Phillips machine. I'm not sure if everybody is familiar with this machine. It's called Phillips machine, or MONIAC, Monetary National Income Analogic Computer. So it is an analogic computer that uses water flows to model the economy. It was created by Phillips in 1949 when he was a student at the London School of Economics. So the idea was to use water to represent income or money or value in an economy. So you could inject water, and you will take that as investment. You could, at the top of the machine, you have the reservoir of water, which represents the treasury, national treasury, and the water goes down, going through different valves and compartments. You have government expenditure, you have wages and things like that, and you have taxes which are represented by you pumping the water back to the treasury reservoir at the top. And it was intended as a teaching aiding device only, but they soon discovered it was 1949. You didn't have many available computers to simulate things, so they quickly discovered that you could actually use this machine to simulate the real economy and to create policies or simulate consequences of policies, and they did use that. It was able, this machine was able to solve systems of 9 simultaneous equations with 9 variables. You could parameterize it, and you could read the solutions by rules attached to the water tanks. So it is a very concrete example of this analogy that you could use a fluid or a physical concept to model an economy. In this, as I was saying before, in this mathematical formulation of economy, it called my attention that the use of the idea of equilibrium was very common, very often. So we can see that, for instance, Debré, which is a very famous and important economist, it has equilibrium in it, and it's in the very title of his book, which is Theory of Value and Axiomatic Analysis of Economic Equilibrium. Samuelson also defines equilibrium in his book, Foundations of Economic Analysis. Of course, there are many different notions of equilibrium in economics. You have short-term equilibrium, you have mostly the idea of a market closure, of supply and demand balancing each other, so you get to a state of rest, economic rest in a sense, a market rest. You have the idea of long-term equilibrium, which is what is going to happen with an economy that evolves, always obeying the short-term equilibrium, what is going to happen in the long term. And when Samuelson talks about equilibrium, I believe it's very interesting to see that he defines the science of comparative statistics, or even the science of economy, as the investigation of changes from one position to equilibrium of another. So economy, the subject matter of economy for him is the analysis of states of equilibrium and the transition from one state to another. And interestingly, he points that by equilibrium it's meant here only the values of variables determined by a set of conditions and no normative connotation attaches to the term. So he tries explicitly to avoid committing himself ontologically or normatively to the idea of an economy in equilibrium. So it's just an artifact. It's quite different from what you see, for instance, in von Neumann, which in his preface for the game theory and economic behavior, he says that what he's doing is not a model, it's the exact behavior of the economy, of the economic behavior of people. He's much more bold than Samuelson. Samuelson tries to avoid the idea that equilibrium should be seen as a concrete or ontologic notion. Okay, so I started, well, since this is all based on the use of mathematical methods, I wanted to understand, well, nowadays you have the equilibrium models are very successful. There's the general equilibrium theory founded by Walras after Samuelson and Debré. And right now, the DSGE models, which are dynamic stochastic general equilibrium models, are very successful both in academia, both in research and in practice of economics, because as we know, the economist maybe is the member of the scientific community that is mostly called upon to produce to help, for instance, governments and companies to create policies and to make decisions. They do that a lot. And right now they use a lot of these kinds of equilibrium models, DSGs, to do that, which for me looks like what Samuelson wanted was not accomplished, because the macroeconomic science is normative because it is used and applied and to actually decide the fate of states and people. So these are models that are very, very successful and very much used today. So as I was saying before, I was interested in the use of equilibrium concept in this model, so I wanted to understand, since I am from the mathematics department, what is equilibrium for in mathematics. So I believe that it is not a precisely defined concept in math. If anybody knows of a use or definition of equilibrium, I would be glad to hear about it. But it is, if we think about mechanical systems, which are the main inspiration for the economic models, we see equilibrium associated with ideas of stationary points, so points where your system is at rest, nothing happens with it anymore, with limiting behavior of a system. So what will happen to a mechanical system if it's left to evolve freely for a long time. Invariant measures in ergodic theory, for instance, you have the idea of equilibrium as a measure or a probability distribution, if you want, over your configuration space, again, which will remain invariant for the dynamics or by the dynamics. The dynamics of the system would not alter this distribution, so this is why it's invariant. And probably the best or the broadest terms in which to which we can relate equilibrium ideas are the concepts of stable objects and discrete objects, in the sense that they in a space of smaller dimension than the original space, which arise as limiting behavior. One example that I find very interesting is the Poincare-Bendixson's theorem in ordinary differential equations, where you have the continuum of space in which a system is evolving, but if you have some if you assume some hypothesis over the system's nature, it ought to be bidimensional. It cannot be three-dimensional. It must have a finite number of singularities. You must be able to contain the orbitals inside a compact set, and some Lipschitz condition on the equations. This system will have only three possible behaviors or three kinds of objects in its limit set, which are singular points, periodic orbits, and homoclinic orbits. So from this continuum of possibilities for the evolution of a system, the use of an equilibrium concept or the application of an equilibrium idea, so to speak, reduces the dimensionality of our space to only three possibilities, qualitative possibilities. So it allows one to trap the system or trap the object which you are studying in a very restricted space, so you can name it and describe it and make predictions about it. Because another important thing about this idea of equilibrium is that when your system is in an equilibrium state, you do not need an infinite time arrow anymore, because it will repeat itself, or it will stay at rest, or it will behave in a regular way. So to create predictions or draw conclusions about a system, you do not need anymore to consider an infinite time axis. So this is one interesting feature of an equilibrium solution or the equilibrium idea. These same kinds of characteristics of which I am identifying with equilibrium concepts in math are seen in other works from other fields. For instance, in the theory of knowledge of von Forster, where he famously says that he's talking about eigenvalues, which are an idea of an invariant object which might or might not arise as a limiting point of a process. He's talking about eigenvalues, and he says that these are discrete, stable, separable, and composable objects which ontogenetically arise as equilibria, so he uses the word, that determine themselves through circular processes. So in this work, von Forster is talking about the theory of knowledge and the interaction between a cognitive being and an environment. He describes that as a recursive process, and he defines the objects of knowledge as equilibria of this process. So concept of equilibrium can be linked to an intrinsic epistemological interest. So it might be interested by itself, because if we understand the process of acquiring knowledge as a system, a recursive system where you are dealing with reality recursively, your objects of knowledge can be seen as equilibrium and arising as equilibrium. So after von Forster, another scientist that uses ideas of equilibrium in self-referential processes or recursive processes is the sociologist Luhmann, who is a little bit, he's bolder than von Forster, and he tries to create this theory of sociology which is made of nested systems, all of them recursive systems, dynamic systems, which are nested inside each other. And science for him is one of these systems, which produces theories as recurrent states or equilibrium states of its functioning. So in the science as a community of people produces theories not only by rational thinking and empirical validation and individual solipsistic work, but as a community working like we are here, for instance, trying to reach agreements or stable positions or stable theories that are capable of explaining some part of reality and that can be described as arising as equilibrium. So this is why probably, again, another hint that ideas of equilibrium are very important. Finally, we have in the epistemology of Thomas Kuhn, he also describes science as a process, a kind of a social process. And I will not go so far as saying that a paradigm for him is an equilibrium, but he describes them as discrete and stable objects which work recursively in their own problems, the scientific paradigms. And this continuous evolution is disrupted by anomaly, which is the change from one equilibrium position to another. In economy, this is what I started talking about. We had an anomaly in 2007. The subprime crisis was unexplained, unpredicted by most theories of these DSGE equilibrium types. So it triggers, after the crisis, a thorough exploration of macroeconomic models, which started to use some of these criticisms and explorations, attacked the concept of equilibrium directly, saying that economy should get rid of it and not anymore think in terms of equilibrium. They proposed models of the type agent-based models and stock flow consistent models, which are not equilibrium types of models. So they had a hard time. They have some success, but it's harder when you do not have an equilibrium object, because as we've seen, equilibrium is a very probably fundamental notion of science. So another thing that was a proposal that was reintroduced after the crisis was the use of thermodynamical methods. So in the paper that I submitted to the Congress, I do a brief review on these papers to understand what can be seen as what is the change that we have in these new models. Basically, we have macroeconomic models for transactions between a finite number of agents which are trading a finite number of goods, and you use now a conservation law of a statistical nature. Market is not going to closure, it is going to closure only on expected values, and your solution by the application of MaxEnt principle is a probabilistic one, a probabilistic equilibrium, which you can use for many things. For instance, to derive predictions, to calculate or quantify your uncertainty about your predictions, because you have now a probabilistic model. It's less ambitious because it allows for you do not try to predict the exact behavior of each individual. You have only statistical laws. You do not have to admit rational behavior of individuals. You allow for the existence of inequality in the equilibrium, so it is a more realistic model. And of course, if we take the interpretation of equilibrium in thermodynamics and the use of probability in thermodynamics and physics, we see mainly two schools of thought, which is the ergodic theory and subjective theory. And what I am trying to say here is that ergodic theory puts the equilibrium reality in the real economy. So it is a normative notion for the real economy, because if you let the system freely evolve, it will reach equilibrium, it will be a real object. But if we apply the subjective interpretation of James, what we have is that it's the second law of thermodynamics is not anymore in the system. So it's not the economy that moves in the sense of increasing entropy, but it is the scientist who maximizes his entropy to be sure that he has the most conservative model that he can. So in this sense, in one sense, maybe the use of this interpretation gets us closer to what Samuelson would want. And it might be important, since in the words of Blanchard, who is chief economist of the IMF, the techniques we use affect our thinking in deep and not always conscious ways. So probably interpreting probability as a subjective measure of uncertainty might get into economists' minds. And if they came to believe that uncertainty is indeed in the way the world works, they probably will be not very much far from the truth. That's it. Thank you very much.